As seems to be true with most of my life, I am sitting in a room completely by myself talking to myself. So nothing new here. I do have some problems to work in series and parallel because one of you lovely people requested that I do a few. So I'll just be working these by myself then, and we'll see if anybody happens to show up while I'm in the middle of saying things. And if not, that's really okay. Uh, So we're going to be looking at resistors in series additional practice, or the word problems, and then follow that up with some of the resistors in parallel. Um, so looking at series, we're going to look at problem number 1 here. Uh, Figure out what's the background information we really don't care about and what's actually important. So large optics diamond turning machine, cut a human hair lengthwise 3,000 times. That's nice. We don't care. That would produce pieces with a cross-section area of 10 to the negative 7th square millimeters. I also don't think we care about that. 1 meter long silver wire with this cross-sectional area would have a resistance of 160 kilohertz. Now that is important, okay, because what that does is that gives us a ratio to work with. We know that for every 1 meter of wire, it's going to have a resistance of 160 kilohertz. So we've got 3 pieces of wire, okay? Piece number 1 is 2 meters, piece number 2 is 3 meters, and piece number 3 is 7.5 meters. So you've got 2 meter, 3 meter, and 7.5 meter. It wants to know what's the equivalent resistance of the connection if we string those 3 pieces of wire together. So if 1 meter equals 160 kilohertz, and we know from our note up at the top of the page that 1 kilohertz equals 1,000 hertz. So in other words, for every 1 meter, we're going to have 160,000 hertz. So very easily, since in resistance, our total resistance equals the sum of all of our resistors. And we just have 3 to work with here. We can do this in a couple different ways. We can either multiply this times each of these and then add them up. I think it might be a little bit easier, though, honestly, to add up the lengths first and get a total length, and then just multiply that by our resistance. So if I add 7.5 to 3, that's 10.5 plus 2. That means that our total length is 12.5 meters, okay, times 160 kiloohms. Did I say kilohertz? It's hard to tell. I'm talking to myself. So when I multiply those, let's see what we get. Calculator. 12.5 times 160. So we get a total of 2,000 kiloohms, or if we want to put this just in ohms, that would be 2 million ohms, because we multiplied by 1,000. We could also, stick that as scientific notation. See, I'm just bored and playing around with things right now. The important thing is, whatever your answer, you need to specify whether you're giving it in kiloohms or whether you're giving it in ohms. Because if you just give me a number, even if it's in scientific notation, I'm not going to know which one you refer to, and you're going to lose points. So that's why units are always super duper important. So that's question number 1. Next question that was requested was number 3. Again, we're still on the series problems. A 3 millimeter thick steel wire that stretches for 5,531 kilometers has a resistance of about 82 kiloohms. If you connect in series 3 resistors with values 16 kiloohms, 22 kiloohms, and 32 kiloohms, what value must the 4th resistor have for the equivalent resistance to equal 82 kiloohms? Well, this is a little bit of a different problem, but it's certainly not a difficult one. Because again, here, our total resistance is going to equal R1 plus R2 plus R3 plus R4. Okay. And so if our total is 82, and they give us our 3 of our 4 are 16, 22, and 32, all we have to do is solve for our fourth one. So we're going to find the sum of these, and then subtract that from 82. So I'm not going to try and do this in my head just in case I mess it up. So 16 plus 22 plus 32 gives us a total right here of 70, which means that our last one is going to be 82 minus 70. 82 minus 70 is 12. So our answer, it wants to know what value must the fourth resistor have. It's going to be 12 kiloohms. Or, if we're going to get picky, 12,000 ohms. But if it's not specifically asking for ohms over kiloohms, then just leave it as kiloohms and use the correct unit. So those two weren't too bad. Checking my cheat sheet here, and it turns out both of those are correct, so rock and roll. Let's take a look now at a couple sample problems from parallel circuits. I was requested on this page to work number 3 and number 5. Okay, cool. So let's start by looking at problem 3. Just a moment. Okay. Problem 3. Cars on the Katoomba Scenic Railway. I am guessing that's in Australia. That just sounds very Australian. Cars on the Katoomba Scenic Railway are pulled along by winding cables. I'm not going to do that. And at one point they move along a 310-meter span that makes an angle of 51 degrees with a horizontal. Oh, lots of fun information. I doubt we'll need most of this. A 310-meter steel cable that is 4 centimeters thick would have an estimated resistance of 2.48 times 10 to the minus 2 ohms. An equivalent resistance of 6 times 10 to the minus 3 ohms can be obtained if two resistors, one having the same resistance as the steel cable, are connected in parallel. Find the resistance of the second resistor. Yeah, like I thought, most of that's going to be thoroughly useless information. So, when we've got a parallel, you need to remember that the way to get equivalent resistance, it's 1 over R total, or the inverse of the total resistance is equal to the inverse of the first one plus the inverse of the second one, and so on and so forth. Okay? So we need the equivalent resistance of 6 times 10 to the minus 3. So what we're going to have is we're going to say that 1 over 6 times 10 to the negative 3 is equal to 1 having the same resistance as the steel cable. So the steel cable has a resistance of 2.48 times 10 to the minus 2, so it's going to equal 1 over 2.48 times 10 to the negative 2 plus 1 over something else, and that something else is what we're going to attempt to find. So we're going to have to play a little bit meaner with our math on this, but it's still not going to be terribly difficult. I'm going to go ahead and I'm going to get some rough decimal values for what each of these are going to be, because to get this by itself, I'm going to have this minus this. Okay? Now, at the very end, the number I get, I need to remember it's actually going to be 1 over the number I'm looking for. So I'm going to have to invert that, or find the reciprocal of that when I find my answer. Don't let me forget to do that, voices in my head. Okay, so for the first one, if I do 1 divided by 6 times 10 to the negative 3, I get a value of this one of 166.67, and it's a repeating decimal. Let's look at the next one. 1 divided by 2.48 times 10 to the negative 2. I get 40.32 plus 1 over what we're looking for. So I can find what 1 over what we're looking for is by subtracting this 40.32 from our 166. So I'm going to go ahead and do that. 166.67 minus 40.32 equals 126.35. So 126.35 equals 1 over our unknown. So to reciprocal this and flip it over, I'm going to have to do 1 divided by this is going to equal that. Now, if you want me to show you the algebra on that, I'd be totally happy to. Basically, what you have to do is you multiply both sides by your unknown, which sends it up to the top on the other side. You divide both sides by this, which sends this to the bottom on this side. So it works. The math works. Just trust me. So what I'm going to do on my calculator, since I've got that answer in there, I'm just going to do 1 divided by, and I'm going to hit my button marked answer. And it tells me that my resistance on that last one is 7.91 times 10 to the negative 3. So that's going to be my answer. Okay, so R2 equals 7.91 times 10 to the negative 3. Now, it's probably a good idea for me to check and see what unit I'm in after I gave you guys a big speech about units. So it looks like these are just normal ohms. So my answer is going to be in just normal ohms. Okay. Just to make sure I'm not an idiot, let me make sure that that's the same answer that they gave in the problem here. Okay. Onakatimba Ryle Y. They're getting a slightly different answer. I'm going to pause for just a moment. No, I'm not going to pause for just a moment. I'm going to see what they did if it's different from what I did. Okay. All right, 6 minus 3 minus 1 over all that. Sure. Okay. So 167 minus... Now they got 80.6. 48 times 10 to the minus 2. Huh. So let me reread the problem. It's possible that I missed something. Okay. Estimated resistance. Equivalent resistance of 2 resistors, one having the same resistance as the steel cable. I think the key is wrong. If somebody's watching this and you want to point out something that I missed, feel free to, and I will add an addendum to it, but I think the key is wrong. Because the key is telling me that I have to double that second one, which doesn't make any sense to me. 4 centimeters thick, 2 resistors, nope, I'm sticking by my answer. So, whatever, physics textbook, what do you know? And let's look at number 5. Now, number 5, I'm not sure that that's a fair request, because there's like multiple questions on number 5, but let's just take a look and I'll see how far we want to work. The largest piece of gold ever found had a mass of about 70 kilograms. If you were to draw this mass of gold out into a thin wire with a cross-sectional area of 2 square millimeters, the wire would have a length of 1813 kilometers. Oh, my family is all leaving me. I don't blame them, really. I'm boring. Bye, guys. Have fun. Have fun storming the castle. I'll probably cut this out on the video. Or maybe I won't. If you were to draw this mass of gold into a cross-sectional area of 2 square millimeters, the wire would have a length of 1,813 kilometers. It would also have a resistance per unit length. Now, that per unit length is, okay, of that much per meter. That's important because that's going to be our resistance for any given meter. And now they want to know the total resistance of the wire. Well, that's easy. That's going to be super easy. So for part A, we're just going to take the length of the wire. Now they give it to us in kilometers, so be careful here. If that's how much it is per meter. So I'm going to change, first of all, our length into meters. So it's going to be 1813000 meters, because a kilometer is equal to 1,000 meters. Okay. Times our equivalent resistance, which is 1.22 times 10 to the negative 2. So that's going to be really easy to solve. We'll plug that into the calculator. 1813000 times 1.22 times 10 to the negative 2. So I get a total resistance there of 22,118.6 ohms. All right. Wait till they roll out so I can hear myself. Bye. Mwah. Okay. Now suppose the wire were cut into pieces having a resistance of exactly 1/2, 1/4, 1/5, and 1/20 of the wire's resistance. If these pieces are reconnected in parallel, what is the equivalent resistance of the 4 pieces? See, this also is not too bad, because what we have to do is we're going to take what the resistance of the entire thing is, and for each of our resistors, we need to say that R1 is going to equal half of this, R2 is going to be 1/4 of this, R3 is going to be 1/5 of this, and R4 is going to be 1/20 of this. So, it's a derby equals there, sorry about that. So, to find this first one, I'm going to take my answer. I'm actually going to, can I just put that in my memory? Nah, never mind. I'm going to take that, and since I need half, I'm going to divide by 2. Okay, so half of that is going to be 11,059.3 ohms. Okay, now I want 1/4. 1/4 is just going to be half of a half, so I'm going to divide this in half again. So divide by 2 again. So 5529.65 ohms. Now to get it back up to 1/5, let's do my original 22118.6. To get 1/5, I'm going to divide by 5. So that's going to be 4423.72 ohms. And the last one is going to be original number divided by 20. So 22118.6 divided by 20. Should be a fairly tiny number. Okay, 1105.93 ohms. Now, they want, if we reconnect them in parallel, and this is the extremely important part of it, it wants to know what the total equivalent resistance is. Total equivalent resistance, remember, we're going to be doing our inverse total there. So, in other words, 1 over our total resistance is going to equal 1 over 11059.3 plus 1 over 5529.65 plus 1 over 4423.72 plus, come on calculator, move it, 1 over 1105.93. Move my big fat head out of the way here. Okay, it should be an O, not a 6. Make sure I can read my own writing here so I don't do something stupid. So what I'm going to do is I'm going to change all of these. I'm just going to do 1 divided by each number to get a decimal. And then I'm going to add them back up and then take 1 over my total to get my answer, because again we have to find the reciprocal of the sum of all of these. So for this first one, 1 divided by 11059.3, no. You could also put this all in as a single operation. You'd get a more accurate answer because you wouldn't be rounding your decimals, but we're going to get close enough doing it this way. It's going to be fine. So I get 9.04 times 10 to the minus 5. Does that up anymore? Not really. Okay. On this one right here, I go 1 divided by 5529.65. I get 1.81 times 10 to the minus 4. Now, you might be wondering, well, Mr. King, why don't you just add all of these 4 numbers up and then do 1 divided by all of those 4 numbers? That's because I know how fractions work. When you're adding fractions, you don't add the denominators. You have to have a common denominator if you're just going to add across the board, and then you add up your numerators. I know it's been a while since you guys probably had to do that, but it's still the thing. Okay? So don't rush me. This next one, 1 divided by 4423.72 gives me 2.26 times 10 to the minus 4, times 10 to the negative 4, I should say. Sorry about that. And I'm going to do 1 divided by 1105.93. I get 9.04 times 10 to the minus 4. Equals 1 over my total. So I'm going to, now that's really interesting. Check that out. How close those are. The only difference is that this is, 10 times smaller than this is. Makes sense if that's half and if that's a 20th. That's a difference of factor of 10. So, whatever. Cool beans. So I'm going to get my calculator. I'm going to add all these up, and then I can't forget to flip it back over. So I'm going to go 9.04 times 10 to the negative 5 plus 1.81 times 10 to the negative 4 plus 2.26 times 10 to the negative 4 plus 9.04 times 10 to the negative 4. So I get a total from that of 1.4014 times 10 to the minus 3. Now that's going to be 1 over my answer, so now I'm going to do 1 divided by my answer to flip it back over. My equivalent resistance is 713.57 ohms. So RT equals 713.57 ohms. Now, if you read all of the foo-for-ah that went with this, the way to check to make sure that these answers are right, your equivalent resistance for parallel should be less than any of your other single resistances, and 713 is certainly less than all of these. So that's your answer to number 5, both A and B. You got a 2 for 1 there. So I'm going to wind this video up. I hope everybody is doing well this week. I'll be back on, I think I said tomorrow morning, to try and take a look at that circuit challenge FET thing. It's a little more complicated than it looks at first blush, so don't rush through that and make stupid mistakes. I'll be on there to help you, so y'all be sure and tune in. Have a great rest of the day.